In this video, we will learn summary statistics and its types, like central tendency, measures of dispersion, and more in detail. Summary statistics are used to summarize a set of observations in order to communicate as much as information about the data as possible. It is a part of descriptive statistics and are used to basically summarize or describe a set of observations. Example: the weight of the population are 45, 57, 72, 52 kilos. Now, if we want the summary of weight of the population, we can say it is the average weight of the population is 56.6 kilo. And now we can describe the population in the simplest way as possible with the average weight. Summary statistics. Summary statistics are categorized under measures of central tendency, which is again further subcategorized as mean, median, mode, geometric mean. Then the second is measures of dispersion, which is divided into standard deviation, variance, interquartile range, and also others like coefficient, skewness, kurtosis, probability distribution, and distribution plots. Measures of central tendency is the value that describes which group of data clusters around a central value. In simple words, it is a way to describe the center of a data set. Again, what is center of data? A single number that summarizes the entire data set using techniques such as mean, average, or median of the data set. Measures of dispersion. Dispersion, also called as variability, scatter, or spread, is the extent to a distribution of data is stretched or squeezed. Here in the graph, we can see the distribution of data. Assume population is more stretched at the right side, ranging from 50 to 80. Let's go further in detail the types of central tendency. Mean is the average of observations, most effective when data is not heavily skewed. Median represents the middle value of the data set, useful for skewed data. We will talk about skewed data in the upcoming slides. Mode means maximum number of times the data has occurred. Geometric mean, nth root of a product of n numbers, is used when we want to get the average rate of the event, and the event rate is determined by multiplication. For example, the growth of a bank account per year in an ABC bank is calculated by geometric mean, since the growth rate is determined by multiplying the amount of bank account by the percentage of growth. Then we will use geometric mean. This is the formula for calculating geometric mean. Here 43.9 means 3 times of 43.9 is 585008. And remember, if one of the observation in the event is 0, geometric mean becomes 0, and also it doesn't work for negative numbers with negative numbers. Mode, as we know, the maximum number of items occurred. For ungrouped data, here mode will be 33, and we can see 33 occurs 2 times, which is the highest among the rest. For group data, the formula will be L plus delta 1 by delta 1 plus delta 2 multiplied by I. Nowadays, we don't have to worry about the calculation, as in statistical softwares like R, Excel, it will automatically calculate the intense calculation for large amount of data, but for more in-depth information, you can visit this link. Now, measures of dispersion is categorized as standard deviation, which is basically a measure of how near or far the observations are from the mean. Then variance, the fact of quality of being different, divergent, or inconsistent. A value of 0 means that there is no variability, all the values in the dataset are same. Interquartile range is a measure of variability by dividing a dataset into parts, that is quartile. For example, Q1 is the middle value in the first half of the data. Q2 is the median value. Q3 is the middle value in the second half of the rank ordered data set. Therefore, interquartile range is equal to Q3 minus Q1. Skewness refers to the lack of symmetry or imbalance in data distribution. In semantic distribution, the data is normally distributed, where mean, median, mode is at the same point. However, in real life, data is never perfectly distributed, hence we call it skewed data. If the left side has longer tail, then the mass distribution of data is concentrated on the right side, which is negatively skewed. If the right side has longer tail, then the mass distribution of data is concentrated on the left side, is known as positively skewed. In this example, if we apply mean is 30.8, it will be incorrect since we can see the maximum number of values are above 35. So we have to use maiden. For ungrouped data, it will be n plus 1 by 2. That will be 3. That is the third term. That is in turn 35. For group data, we have different formula. Again, we don't have to worry about the calculation as in any statistical software like R, Excel will automatically calculate the intense calculation for large amount of data. Kurtosis is a measure of whether data are peaked or flat relative to normal distribution. It is divided into three types. Leptokurtic, this means the distribution is more clustered near the mean and has relatively less standard deviation. Platykurtic, where the distribution is less clustered around the mean and a standard deviation more than leptokurtic. Mesokurtic is typically measured with respect to the normal distribution. Mesokurtic has tails similar to normal distribution, that is neither high nor low. Rather, it is considered to be the baseline for the other twos. To check the data is skewed or not, type SKEW, select the range of values. If we have values like minus 0.27 means negatively skewed. And also to check the kurtosis, type KURT with a range of values. If it is in minus 1.6, then it is platykurtic. Before we end our chapter on this, let us recap what we have learned so far. In detail, measures of standard tendency, measures of dispersion, measures of risk. Next, we will see how to compute this theory in practical and analyze any data using our everyday simple tool like Excel.